So today's lecture we will mainly discuss about delta A, which is the enthalpy change. We will relate this delta H with vibrations of atoms, then the entropy change taking place, the reaction kinetics, the Gibbs free energy change, and if time permits, we will also discuss about the probability of existence of atoms during vibrations, and we will relate this one with something called, with quantum mechanics. Right, so this is the whole topics that we will discuss today. So first, let me start with the concept that change in entropy is related to the enthalpy change divided by the melting temperature. Right. So, whenever the temperature is more than 0 Kelvin, the vibrations, atomic vibrations start. Two atoms vibrate करने लगते हैं. Now, if you plot the vibrational energy, so if you plot the vibration energy with respect to the distance, you get a plot like this. The atomic distance. Now, the energy of vibration is not continuous. It has got different states. Right? These are called vibrational energy states. Now, quantum numbers, I think you have studied quantum numbers. You know what is a principal quantum number is, what is an angular quantum number, azimuthal quantum number, or spin quantum number. ये चार quantum numbers के बारे में तुमने पढ़ा in the case of atoms. In the case of molecules, you can divide molecules. मतलब हम लोग यहाँ पे consider कर रहे हैं very basic model of a molecule, जहाँ पे हम लोग assume कर रहे हैं कि there are two atoms combined by a bond. So let's call these two atoms कैसे हैं? They have been combined by a bonding, very simple. So इसको हम लोग usually we call this one as rigid rotator bonding. Call this one as a rigid rotator bonding. और molecular energy total energy of a molecule, total E. Molecule may, if we are considering the total energy of a molecule, it comprises of three different types of energies. Three different types of energies. First one is, let's say it's called vibrational energy, means for both of EV, plus, I take this, one as rotational energy ER, the last one, plus plus electronic energy. Okay, vibrational, rotational, and electronic energies. And these three energies are independent of each other. ऐसा नहीं कि due to this there is a change in this and that. So this relationship, इसको हम लोग बोलते हैं bond Oppenheimer. Oppenheimer का नाम तो सुना होगा. Bond Oppenheimer relation. बेसिकली क्या बोल रहा है कि जो तीनों एनर्जीज हैं, वाइब्रेशनल, रोटेशनल एंड इलेक्ट्रॉनिक एनर्जीज, दे आर इंडिपेंडेंट ऑफ ईच अदर. तो हम लोग फिलहाल वी आर फोकस्ड ऑन द वाइब्रेशनल एनर्जी. सो वाइब्रेशंस में दे आर एटम्स वाइब्रेटिंग. एज यू आर गोइंग अप, द वाइब्रेशंस एम्पलीट्यूड्स आर इंक्रीजिंग. ठीक है, यहाँ पर जो वाइब्रेशनल एनर्जी है, जो ईवी है, we can represent this E as B plus 1 by 2 H nu. B plus 1 by 2 H nu. Now what is the nu? Is the oscillation, जिस frequency से oscillate कर रहा है, vibrate कर रहा है. H तो लोग जानते हो, Planck's constant. This B is the new, इसको हम लोग बोल रहे हैं वाइब्रेशनल क्वांटम नंबर. Vibrational quantum number. This is photons. In the case of photons, how do you represent the energy? NH. What is N? N is the number of photons. Right. इसी तरह से यहाँ पे we are representing the vibrational energy as V plus half H nu. यहाँ पे if this corresponds, ये जो state है, the lowest energy state, it corresponds to V is equal to 1. Sorry, V is equal to 0. इसके ऊपर है V is equal to 1, V is equal to 2, and so on and so forth. So at V is equal to 0, E0, कितना होगा इसका वैल्यू? What will be its value? How is it? इसी को बोलते हैं 0 point energy. यहाँ पे another interesting fact is that you know that an atom का configuration कैसा होता है? Atom, we have nucleus and उसके side में we have electrons. In what form are they? जो इलेक्ट्रॉन्स होते हैं न्यूक्लियस के बाहर, वो क्लाउड फॉर्म. क्लाउड ऑफ व्हाट? इलेक्ट्रॉन, वो जो क्लाउड बोलते हैं वो क्या है एक्चुअली? इलेक्ट्रॉन का क्लाउड मतलब क्या है? Normally, मैं बोलता हूँ इसको. So there is a cloud, right? पहले Bohr's model था, where he used to say that it is revolving around it. Then it was found that it's not revolving; it's in the form of a cloud. ठीक है, you are right. It's an electron cloud. ये जो cloud है, what does this actually means? Cloud of what? Cloud of probability. ठीक है, cloud of probability. Look, s orbital, p orbital. I think you have studied. What is the shape of an s orbital? Spherical. What is the shape of an p orbital? Double shape. उसके बाद ये ना, so जब कोई बॉन्ड बन रहा है, मान लो एक कार्बन, कार्बन का जो फर्स्ट लेयर, एटॉमिक लेयर, कैसे कैसे दिखता है? है ना? लेकिन इसको क्रॉस सेक्शन में अगर हम देखें तो कैसे होगा ये? एक हेक्सागन, एक वन हेक्सागन, यहाँ पे ऐसे बॉन्ड है, bonds ऐसे करना है. So what is actually happening is these are electron clouds. उसी तरह से you have electron clouds in this plot also. At the center, जो zeroth state है, वहाँ पे you get electron cloud like this. But as the vibrations increase, electron clouds separate out. ठीक है? So it represents psi square. Probability of finding electron. So closer you are towards the bond order, closer is the probability of finding the electron if you are not having that much of energy. Right? अच्छा, ये जो term है psi square is probability, all right. What do you mean by psi? इसको हम लोग बोलते हैं wave function. Call this as wave function. श्रोडिंगर्स कैट के बारे में सुना है तुम लोगों ने? मैं बोल देता हूँ क्या है. श्रोडिंगर्स कैट का भी सेम कॉन्सेप्ट है. If there is it may be something else. It may not be a cat, a person, whatever it is, an object placed inside a box. Okay, what the Schrodinger is that it is also outside the box. What is making it outside the box? The probability that this object can be outside the box makes it outside the box. Yes, right. So it is little difficult to visualize the thing. लेकिन इसका application तुम अगर देखो, it gets application in a process called tunneling. Tunneling का बेसिक जो फंडा है वो है, suppose you have an energy barrier, right? You have an energy barrier, it's called this one as E. And there is a particle or whatever a wave coming, which is having an energy E, but this energy is lower than the energy barrier. So no way it can cross it. But what, according to the Schrodinger's equation, the probability that it can be at that side makes it at that side. ये बहुत ही subatomic level पे this is possible. Normal physical it's not possible. So why I am discussing this? Because of the fact that vibrations, when we are talking about, now we are coming to the thermodynamic aspects of the whatever I have told you. Whenever two atoms are vibrating, suppose in a solid, you keep on increasing the temperature. Let's say any copper or anything. So तुम अगर temperature देते जाओगे, तो ultimately what will happen? It will melt. In the case of metal, it will melt. So at the point of melting, what happens is that an extra energy enthalpy basically you can call it as the heat which is inside the material. This extra energy is called enthalpy of fusion. That gets added to the melting temperature. ठीक है? Enthalpy of fusion. So, एक second. Now, the question is how much is the entropy? For that, you understand that at room temperature, by room temperature at 27 degrees Celsius, G is equal to, at room temperature, when two atoms are vibrating, they can vibrate in three different modes, X, Y, and Z. Give me one mode, so the energy of vibration is K into T. Okay. What is K? Is the Boltzmann constant. Value कितनी होती है? 1.38 into 10 to the power 23 joules per mole per Kelvin. Now, just to a problem. The enthalpy of fusion of ice is 6.20 kilojoules per mole. 6.20 kilojoules per mole. Heat of fusion. Fusion मतलब हम लोग बोल रहे हैं that means melting point. You have to find out what is the entropy change taking place for the when ice melts. यहाँ पे तुम कैसे करोगे? आइस मेल्ट्स मतलब क्या? हाँ हाँ ठीक है। मेल्टिंग पॉइंट ऑफ आइस कितने में होगा वो? 0 में ही होगा। 0 से थोड़ा सा बढ़ेगा, लेटिंग हीट जिसको बोलेंगे, 0 से थोड़ा सा जो बढ़ेगा देन इट विल स्टार्ट टू मेल्ट। सो व्हाट इज दैट इज कॉजिंग इट टू मेल्ट? 0 डिग्री पर आइस है, तुमने इसको आइस को यहाँ पे रख दिया है, इट विल स्टार्ट टू मेल्ट इवन इफ इट इज एट रूम टेम्परेचर। ओके, बट व्हाट इज कॉजिंग इट टू मेल्ट? This is the enthalpy of fusion, delta H, right? So find the entropy. Entropy कितना है? इसको क्या करना है? आइस मेल्ट 0 डिग्री को 0 डिग्री सेल्सियस मतलब इट्स हाउ मेनी केल्विन? 273.17। एंट्रोपी कितनी हो रही है इसमें? जस्ट यू नीड टू डिवाइड इट by this one, so it's 6.20 kilojoules per mole divided by 273.15। कितना आंसर आ रहा है? डिविजन करना इम्पोर्टेंट नहीं है, इम्पोर्टेंट है कि टू अंडरस्टैंड द कांसेप्ट दैट द हीट ऑफ द एंथैल्पी ऑफ फ्यूजन नीड्स टू बी डिवाइडेड बाय द टेम्परेचर एट व्हिच द आइस इज। मतलब एक्स्ट्रा टेम्परेचर हम लोग नहीं देंगे, बिकॉज ऑफ दैट एंथैल्पी ऑफ फ्यूजन ओनली इट स्टार्ट्स टू मेल्ट 0.03। हाँ 0.03। एंट्रोपी जो है लिक्विड का एंट्रोपी और से सॉलिड का एंट्रोपी, दोनों में से कौन? एंट्रोपी मीन्स डिसॉर्डर। ठीक है, तुमको क्या लगता है किसमें डिसऑर्डर ज्यादा है? सॉलिड में है कि लिक्विड में है? लिक्विड में डिसऑर्डर ज्यादा है। डिसऑर्डर मतलब नॉट इन ऑर्डर। ओके, सॉलिड में क्या है? द ओनली डिसऑर्डर दैट कैन ऑकर इज द वाइब्रेशंस। लेकिन लिक्विड में क्या है? देयर आर नो वाइब्रेशंस बट द एटम्स कैन फ्रीली मूव अराउंड ईच अदर। सो एंट्रोपी इन द लिक्विड इज मोर देन एंट्रोपी इन सॉलिड। सो जब आइस मेल्ट हो रहा है, when the ice is melting, ice melts, so there has to be some increase in entropy, so delta S should be positive. Right. So ये पॉजिटिव करने के लिए, लिक्विड टू सॉलिड स्टेट में आने के लिए, what is the thing that the ice requires? Temperature. Temperature तो हमने दिया, but in terms of heat, it's the enthalpy. So that enthalpy can be found out, is related to the entropy by this formula, and this is how you can calculate. Right? अच्छा, मैं तुमको और एक let me move further on, then you will be able to understand. जो entropy है, erase it. Let's not erase it. This entropy has got two forms. Entropy S, one is called S, let's call it as PH, और दूसरा है SCF. STH stands for thermal entropy or thermal disorder. जो कि वाइब्रेशन से हमको मिलते हैं, increase the temperature, thermal temperature increase. Configuration entropy is a disorder which occurs due to number or arrangement of the atoms. Configuration, how the atoms are arranged. ठीक है, जैसे यहाँ पे for example, suppose you are sitting in this classroom, you are arranged, right? You have got a certain row, certain column. यही चीज अगर मैं ऐसा कर देता हूँ कि I don't keep any bench and desk, just roaming around, so the disorder will increase. So that is what is a configurational entropy is. In terms of material science, I will tell you what exactly this means and how is it applicable. बहुत ज़्यादा इसका application है. How से मतलब कितने चीजें कितने एक से एक कितने linked हैं, that we will be able to understand. Crystal के बारे में you have some idea? Yes. Crystal, the word crystal is basically it comprises of two things. One is lattice, another one is basis. मोटिफ भी बोल सकते हो, बेसिस भी बोल सकते हो. Some is also called a motif. M-O-T-I-F. What is it actually? Lattice means points in space, equally arranged points in space. वो हम लोग यहाँ पे 2 dimensionally show कर रहे हैं, but it can be a 3 dimensional arrangement of space. Lattice corresponds. Now, to each lattice point, if we place one atom or a combination of atoms which are similar, यहाँ पे एक atom भी हम लोग place कर सकते हैं, AB lattice, or we can place a combination of atoms, but it should be similar. मान लो 2 atom, 3 atom, whatever. Then it forms a crystal. Now, during the formation of the crystal, it's not that every crystal is perfect. कोई भी crystal perfect नहीं होता. थोड़ा उसमें defects होते हैं. Crystal जैसे बना, there will be crystal defects also. Defects को हम लोग अलग-अलग dimension में divide कर सकते हैं. For this configuration entropy, the defect that is important, that is called point defect. Point defect. Point defect. दो तरह के point defect हो सकते हैं. One of them is called Frankel defect. And another one is called Schottky defect. I think you plus 2 is going to buy Frankel. What is a Frankel defect? Well, there is an absence of atom at a particular site, and it has gone to another interstitial site. The total इसका दोनों का जो concept है कि the charge should be neutral. ये Schottky defect is equal number of anions and cations missing. If there is 2 cations missing, there has to be 2 anions missing as well. That creates a Schottky defect. और ये है कि positional change हो रहा है, right? तो इन दोनों के cases में both of them are based upon 2 things. एक है vacancies. Vacancies, and the second one is interstitials. Vacancies and interstitials. Now, these vacancies and interstitials are also important in the case of alloy formation. So let's take a situation